In this lesson, we are going to be multiplying rational expressions. So we're going to start off by reviewing factoring. So we have our trinomial. What two numbers multiply to be -6 but add up to be 5? That would be 6 and -1. So we have x plus 6 and x minus 1. In our next example, what two numbers multiply to be 2 but add up to be -3 would be -2 and -1. So that's going to be x minus 2 and x minus 1. In our last example, we see that we have a greatest common factor of 3x. And so when we divide by 3, we get 4x squared plus 3. And that one we are done factoring because that is not a difference of squares. And the most important part to remember when we are multiplying or simplifying rational expressions is that we need to factor first, unless we can't. So in this example, when we factor first, the numerator is 4x squared, and in the denominator we have a greatest common factor of 4x, and we have x squared plus 3, which cannot be factored still. So the 4's we can simplify. 4 divided by 4 is 1, and 4 divided by 4 is 1. And then we have an x and an x squared, which means we have an x left over. So our final answer is going to be x over x squared plus 3. In the next example, we'll factor the top. -6 and -5. So what two numbers multiply to be -6 but add up to be -5 would be -6 and 1. So we have x minus 6 and x plus 1. And then we have the difference of squares, which would be x plus 1 and x minus 1. And so we would simplify the x plus 1's, which is only that entire quantity. And what we have left is x minus 6 over x minus 1. So when we're multiplying, we have a choice. We can multiply straight across and then simplify, or we can simplify first and then multiply. So in this case, I'm going to simplify first and then multiply. So I know that 5 goes into 5 once, and 5 goes into 25 5 times. 3 goes into 3 once, and 3 goes into 9 3 times. Then we have an x and an x squared. So x can be divided into itself, and it goes into x squared 1x time. So now we can multiply straight across. 5 times x is 5x, and 3y would be left in the denominator. And you would get the same exact answer if you would have multiplied across first, which would be 75x squared on the top over 45xy, and then simplify. You would get the same exact answer. So you can simplify first, one numerator and one denominator, and then multiply, or you could multiply and then you could simplify. So in this case, I'm going to try the other method. I'm going to multiply straight across, and then I'm going to simplify. So 6 times 10 is 60, and then I have an x squared and an x cubed, which would be x to the 5th when they're multiplied together. And then a y cubed and a y to the 4th, which would be y to the 7th when we multiply. On the bottom, 2 times 18 is 36. And then we have an x squared, and then we have a y squared and a y squared, which would be y to the 4th. So now we're going to simplify. So we know that 6 can go into 60 10 times, and 6 can go into 36 6 times. But I still can simplify, so 2 goes into 10 5 times, and 2 goes into 6 3 times. So now that I have the fraction, the numerical portion simplified, I'm going to simplify the variables. So I have x to the 5th on the top and x squared on the bottom, and when I simplify that, if I take 2 x's away from the top, I would have x cubed. And then the y to the 7th and y to the 4th, I'd have a y cubed left. So in this example, I multiplied first and then I simplified. Now, when we're working with larger numbers and larger expressions, we need to make sure we factor first. So on 5x squared minus 45, we would divide by 5, and we would get x squared minus 9. And we have an x plus 3 in the bottom, which can't be factored. And then we can take a 4 out of the next expression, and we get x minus 3. But in the top, x squared minus 9 can still be factored into x plus 3 and x minus 3. Now that we have it all factored, we can simplify. So x minus 3 divides with x minus 3, x plus 3 and x plus 3. So our final answer will be 5 over 4. In the next example, we want to make sure that we are simplifying first. So what I would do is rearrange this to put my negative 27x cubed first, and then my 3x, so that I have it in standard form. I'm going to divide by negative 3x as my greatest common factor. So negative 27 divided by negative 3 would be 9. X cubed divided by x would be x squared. 3x divided by negative 3x would be minus 1. So now I'm going to factor each of these, if I can even more. So I have my negative 3x, and then 9x squared minus 1 is the difference of squares. So we have 3x plus 1 and 3x minus 1. So then the second numerator, we can make our x, and we say, what two numbers multiply to be 3 but add up to be negative 4 would be negative 3 and negative 1. And then we need to make our box to do our 3x squared and our 1. And then we have negative 3x and negative 1x. So when we find the greatest common factors of each row and each column, we'd have 3x minus 1 and x minus 1. Below that is a 3x that can't be factored. Then we'll factor this left-hand denominator. What two numbers multiply to be negative 3 but add up to be negative 2 would be negative 3 and 1. And then we need to make our box. So we have 3x squared, negative 1, negative 3x, and 1x. So we have 3x as our greatest common factor and 1, and then we have x minus 1. So we have 3x plus 1 and x minus 1. And now we see what we can simplify. So 3x and 3x, which leaves us with our negative sign. Then we have a 3x plus 1, we have an x minus 1, and we have a 3x minus 1. Whoops, that 3x minus 1, we need to have both of them in the top. So we have a negative 1, and we have 3x minus 1, the quantity squared, as our final answer. Okay, next problem. The second piece is going to be over 1. So we have our x plus 2 in our numerator. That cannot be factored. In our denominator, that is our cubic function patterns. We're going to do the sum of cubes. Cube root of 27x cubed is 3x. Cube root of 8 is 2. Then remember, you square the first term, change the sign, multiply the two together, and then square the last term. So that would be times, and then looks like we have the exact same polynomial or trinomial on the top over 1. So to simplify, we can cross those out. They will simplify, and our final answer is x plus 2 over 3x plus 2. And even though those two look similar, they are not the same, so they cannot be simplified. So here are two problems for you to try where you are multiplying rational expressions. Make sure on problem 2 that you factor first. And on number 1, you can simplify first and then you can multiply, or you can multiply and then